I would like to welcome everyone on today's ConSteel webinar. This webinar will demonstrate the changes in the automatic meteorological load generation ConSteel version 9 according to the EuroCode 1. Let me introduce myself. My name is Roland Doka. I have recently started to work for ConSteel Solutions Limited as a support engineer, and I am going to be the presenter today. Some practical information about GoToMeeting. You can hide this side panel with the red arrow button, and if you have any questions during the presentation, you can ask them at the questions tab. And I am going to check these questions at the end of the webinar and give answers for them. Please let me promote our summer webinar series, that contains 3 presentations. Last week, the first one was held, that was about the crane loads according to the EuroCode 1. And if you have missed it for some reasons, you can already find it online on our YouTube channel. Today, this is the second presentation, and it is about, just like I said, about the meteorological loads. And on next week, Wednesday, at the same time, like now, the last webinar of the series will be held about special modeling and calculation of the corner zones in case of tapered or hinged frames. Okay, so the content of today's presentation is the following. I will show the method of meteorological load generation for both 2D and 3D models, as well as the determination of the necessary load cases, wind and snow parameters settings, and there are new features, for example, like wind friction, and changes in the old ones too, which I would like to show you. In a few minutes, I would like to tell some words about the conception of the snow and wind load calculation in EuroCode. By the EN 1991-1-3, the formula for the calculation of snow loads for roofs in persistent and transient design situations is given, and you can see it here at the top. The result is depending on the shape factor, which takes the geometry of the roof into consideration, the CE factor, which is the wind factor, and it is depending on the surrounding terrain. The temperature factor is the next, which is used to decrease the value of the snow load because of the temperature loss. Usually the value of this factor is 1, but for example, in case of glass roofs, it can be lower than 1. SK is the characteristic ground snow load, which can be calculated by a given formula or snow map according to the national annex. In accidental design situations, an additional factor, the exceptional factor CESL, is used to multiply the characteristic ground snow load, giving the characteristic value of exceptional snow load as a result. The value of this exceptional factor is recommended. It's 2, but national annexes can define it other. Some words about the wind calculation. For wind calculation, the EN 1991-1-4 is used, and it defines the expression for the calculation of wind pressure acting on the external and internal surfaces. In the expression, peak velocity pressure is multiplied with an internal or external pressure coefficient. National annexes may give rules for the determination of peak velocity pressure, what you can see on the picture. This is the recommended expression. Basically, peak velocity pressure is increasing with the level of the site altitude. CPA pressure coefficient For external pressure, the values for this are given in tables in EuroCode, and for the internal pressure coefficient, values are also given in the standard, and in other cases, it can also be calculated from the CPE external pressure coefficient factors. There is a new function in ConSteel 9 which is taken into consideration when generating wind loads, which is the wind friction. Wind friction can develop on the external surfaces of the structure, which are parallel with the wind direction, and it is acting on a calculated reference area, AFR. The dimension of the building has to be big enough, parallel with the wind direction, to be able to develop the wind friction. Every necessary parameters are calculated in ConSteel automatically. CFR friction coefficient is given in the standard for different surface types, and these values can be seen on the bottom right part of the picture. For example, smooth, rough, and very rough surfaces are defined. Okay, now I'm going to show how to define these loads in ConSteel. First, I'm going to demonstrate on a 2D model, which is a simple frame. Here is the frame. It's 20 meters wide, 7 meters top height, and it's made with a 5.5 meters column height. The purlins are modeled with y-direction supports. So the first step when defining meteorological loads on a 2D model is to define the load cases, because this load generation for a 2D model is working in a semi-automatic way in ConSteel. So first I'm going to define wind load groups and snow load group. And in the wind load group, I'm going to create 3 different load cases. The first one will be the plus X, which is going to be dominant wind section, for example. A plus X2, which is going to be the dominant pressure case, and the longitudinal plus Y load case. For the snow loads, I'm going to generate 3 load cases, the usual 3 load cases: the total snow load and 2 partial snow loads, partial 1 and partial 2. With the OK button, I can apply these load cases, and in next step we can start to define these loads. Loads can be defined with the line load function, but first we have to select the members where we want to define the wind or the snow loads. So I select the dual pitch roof, click on the line load, select the wind load properties, and here we have the settings which we have to adjust. First one, I'm going to set the external pressure parameters by clicking the 3 dots button here. Global wind parameters of the structure has to be set by clicking the 3 dots button here. We have to define the direction of basic wind direction in the global coordinate system. Basically, it's plus x, which is going to be okay for us now. So that means the wind direction is the global x coordinate. We have to set the building dimensions parallel with the wind direction. Our structure is 20 meters, and let's say that perpendicularly it is 20 meters long. With the OK button we can apply these settings. We have to set the surface types because we selected the roof of this frame. I'm going to set to do a pitch roof. Here you can see that the parameters are gathered from the model. The top height, the width of the building, and the pitch of the roof is shown here. Next thing we can set is the position of the frame. It can be set from 0 to 1. So if I say that our frame is in the middle of the whole building, I'm going to set it 0.5, and as you can see, this red line is placed to the middle. But now I'm going to set to 0.1. Next parameter to set is the frame distance. It's 5 meters now. And down here we can find the load cases, the wind cases for this wind load. The first one is the suction, when the whole roof is suctioned. Second and the third case is a mixed case with suction and pressure too, and the fourth case is just a pressure case. The values are quite low because the pitch of the roof now is not too big. As this is the suction case, I'm going to set the case 1. Let's click OK. Let's set the velocity pressure, since it needs to refresh this value. Currently I am in the EN recommended values standard, and by this the fundamental value of wind is 25, but I can set it manually, or I can use maps to choose a correct value which I want to use. For example, let's say it is somewhere over here, and the fundamental value is set to the proper value. By OK, we can accept these changes. We can set the terrain category. Let's set it to the second one, and with the OK button we can apply the changes. For the internal pressure, we can set this parameter manually, but because it is a suction case, I'm going to set 0.2. Another thing which is a new thing in ConSteel 9, that we can choose the direction of the placement. So because of some reasons, for example, we rotated the member on the model. For now we couldn't generate these line loads because it could be placed only to the Z direction, but now you can change it to the Y direction. Z it's going to be okay now, and if everything is set, we can place the load with the pipe button here. Next step is to place the loads to the columns. As always, we have to select the column, click on line load, wind load parameters, and the only thing we have to set now is the external pressure parameters. The surface type is now a wall, and for the wind direction, it is now a front wall. Frame distance is 5 meters, and we can see the actual CPE values. With the OK button, we can apply it. Another refresh is needed to the velocity pressure, because the reference height is different for the column than to the top of the building. I mean, for the dual pitch roof. With the OK button, we can apply, and with the pipe button, we can place the load. To the other column, it works the same. Only thing we have to change the wall view. It's now not the front wall, it is a back wall. With the OK button, we apply the changes, and with the pipe, we can place the loads. Okay, so we have our first load case, the wind section, which is unfortunately placed on the wrong load case because I put it in the load case here. But that's not a problem, because if we select these loads, we can put it to another load case on the property bar. I will select the +X, and with an enter, change is applied, and we can continue to the next load case, which is +X2. First, I'm going to put the loads to the roof. Select the line load. Select external pressure. It is a dual pitch roof. Parameters are still the same, but now it's not a suction case. It is a pressure. It's going to be a pressure case. Okay, and to be a dominant pressure load case, I'm going to set the internal pressure to -0.3. With the arrow, I will place the loads. Let's do it again. So it's 0.0.3. Okay. Next step, the columns, which are perfectly the same as before. Surface type wall. Now this is a front wall. Accept it and place the loads. The other column is going to be a back wall, and place it. One more wind load case is left to generate. The +Y. First step is to change the surface type, since it is a dual pitch roof. Change the wind direction from the +X to +Y by clicking the 90 degrees in the drop-down menu here. Only one wind case we have, and by clicking OK, we can accept the changes. The columns, which are now sidewalls, has to be placed. We can choose that which zone we want to use, but A is the dominant, so it's going to be OK now. The other column is the same, so I don't need to change any parameters. Okay, so we have all of our wind load cases. Next step is to define the snow load cases, which is going to be more simple. We have to click the snow loads and the line loads function. We can choose that if we want to place snow load or exceptional snow load. The parameters can be set manually. Only thing we have to define is the shape factor. Now we choose the dual pitch roof. Parameters are gathered from the model, which can be seen here, just like before. The frame distance is 5 meters, and down here we can see the 3 load cases, snow cases, 2 partial loads and the total snow load. First, I'm going to place the total snow load by clicking the pipe button here. Okay. The partial one, snow load. Okay, and place it. Partial 2 is the last. Okay, so now we have all of our meteorological load cases. We can check the parameters anytime during the modeling phase of these loads by selecting them, and on the properties bar we can check the CPI values, frame distances, load intensities, all of the parameters which are taken into consideration for the calculation of the load intensity. After that, we can create the necessary load combinations, and after that we can continue to the analysis and the design of our structure. Okay, let's move on to the 3D model. I made a model which is a hole with hinged frames. The dimensions are pretty much the same, so it's 20 meters wide and 40 meters long. This hole has a crane path, which is also a new function in ConSteel. Okay, and let's place the loads. I already defined some load cases, the dead load and installations, and the crane load. In 3D, we don't have to generate manually the load cases. They are automatically generated during the load generation phase. But for this, we have to define first load transfer surfaces on the structure by selecting the load transfer surface function, and on the dialog we can choose many drawing functions. Now we need the drawing of a leading rectangular function. So I'm going to select it, change to line view, and draw the load transfer surfaces. Distribution of the loads on this load transfer surface can be automatically defined by ConSteel, which means it's going to distribute the loads, all members, in the surface plane, but we can give them manually the members which should be taken into consideration during the load transfer process. On the model, the selected members are highlighted with this yellow color. Now I'm going to apply it. We can use draw polygon function to draw unusual shaped geometry. We don't have to finish the whole drawing of this polygon. By clicking the right mouse button, the program will automatically finish this polygon. Okay. One very important thing to check before the load generation, before the meteorological load generation, is to check the global Z, the local Z coordinate system, system of the load transfer surfaces. So I'm going to make visible the local coordinate systems of these load transfer surfaces here down. The z-axis of the local coordinate system has to be pointed outwards from the building in case of a correct load generation. So this is always have to be checked, and if it's bad like here, it is have to be turned in structural members tab and on the set local coordinate system dialog with this icon. And as you can see, it is now turned outwards from the building. We have to do this on all of the load transfer surfaces. Okay, it seems to be almost okay, but this is still not good. Okay. Oh. Okay. Now it is okay. So the next step is to define these load transfer surfaces, which we just drew as meteorological surface, which icon can be found here with the airbag and the snowflake. We have to set the surface category, which is going to be a wall, the velocity pressure, which works the same just like before on the 2D line load generation. We choose a fundamental value of the wind velocity. Click OK. Choose a terrain category and click on OK. Next step is the internal pressure, which is developed a little bit after the 8th version of ConSteel, because so far we only had one internal pressure case, and now we have two by clicking the alternative internal pressure factors checkbox down here. So for a wind direction we can set different internal pressure factors. Now I'm only going to use one case. For example, for the 0 direction it's going to be plus 0.2 and 0.3 to the 90 degrees. By clicking OK, we can apply the changes, and the next step is the wind friction. By clicking the 3 dots button, we can define the surface type of this hole, smooth, rough, very rough, and we can define our own friction coefficient factor by setting the CFR value down here. Usually reefs and faults has a very rough surface, so since this is a standard hole, I'm going to use this option. Geometric parameters has to be set. Just like before, the wind direction is the plus x by the global coordinate system. Parallel and perpendicular dimensions are set. By clicking OK, we can accept the changes. Snow parameters can be set also here. We can define the wind coefficient, factors, characteristic snow load, and we can choose the snow load zone, which we only have one now. So I'm going to apply these settings, and we can place our meteorological surface on the load transfer surfaces by clicking them. If everything works fine, a small airbag icon should show you that this load transfer surface now works as a wind surface. Next step is to define meteorological load surface on the roofs. So the surface type is a dual pitch roof. All other parameters can be left unchanged. And by selecting both of the roof load transfer surfaces, this meteorological surface will be placed. And as you can see, it is now also a wind surface and a snow surface, which is why this snowflake is here. Okay, the next step is to define the load cases which will be generated. Generation can be started with this button, the meteorological load generator. At the dialog, we can define that what we want to use to the load generation. So, for example, if we click these checkboxes, all pipes will be placed and load cases will be generated in Y, 90, 180 and 270 degrees direction. Since it is a symmetric building, I don't need these load cases. But if I want, I can define different parameters for different directions. For example, I left internal pressure out from the 90 degrees and wind friction only generated in the 90 degrees. If I want to. Exceptional snow load case can be generated, and with the OK button we can start the load generation. A message will pop up if the generation is successful, and also for the snow generation. And as you can see, all of the selected load cases are generated. 4 load cases for the plus X direction, which we had 2 in the line load generation. First one is the suction, and this is the pressure case. We have 4 cases when we have internal pressure, and 2 cases for the longitudinal load case, one with internal pressure and one without internal pressure. The 3 load cases, which is the total, and the 2 partial snow load cases, just like at the accidental snow load group. Total, partial 1 and partial 2 is generated. And we can check the wind friction on the building, which can be seen here. This is the reference zone where this friction appears. By clicking it, we can check the parameters: the friction coefficient, velocity pressure, and the load intensity. But if we select any of these loads, we can check its parameters by clicking the wind surface. And then, for example, we can check the calculated CPE values and the standard CPE values, which are used for the interpolation in our case. We can check the geometric parameters, internal pressure parameters, wind friction, and the velocity pressure too. Okay, we have finished. After all of these necessary load cases are generated, combinations can be generated. Yes, and if I'm here, this is also a new function in ConSteel, that in ConSteel 9, that we can select that which of the load cases should be used for the load combination generation. If we check the boxes, the checked load cases will be used for the combination generation. Okay. Well, I think that was all. I would like to thank you for your attention and for your participation. See you on the next webinar, which is going to be held on 24th of June, same time as now. Goodbye.